All right, in this lesson, I'll introduce the pandas timestamp object. And the timestamp is basically pandas' version of Python's datetime. So it represents a single timestamp or a single moment in time. And it can have dates and times. It doesn't need the time component, however. And much like Python's datetime object, if the user does not provide a specific time, it's just going to default to midnight on that day. So midnight is 000 in terms of hours, minutes, seconds. So let's take a look. I'm going to call the timestamp method, or create a new object from the timestamp class rather, in the pandas library. So we'll begin with PD and use our dot syntax here. So just like we created a series or data frame, we can create a timestamp object, and it begins with a capital T, and we have it right here, timestamp. Let's open our parentheses, and of course we have to give it a timestamp input as the first argument. And what's great about pandas is it's very smart, as I'm sure you all know by now. So it can actually accept a wide variety of inputs. It can accept strings in a variety of different formats, as we'll see in just a few moments. It can also accept Python datetime objects, so many different things. Let's begin with a couple strings, and I'm just going to type it in randomly. I'm going to do, let's say, a year, 2015, and let's say I stick with dashes, because that's the way I like to do things. Dash, let's do March 31st. So I have the year dash the month dash the date, and there it goes, generating a pandas timestamp. You can see because we didn't specify a time, it defaulted to midnight. So the dashes approach, as you can see, works. What if I write my dates with slashes? What if I do the same date but slash 0331? There we have it again. Pandas had no problem generating it. What if we like to separate everything by commas? Let's do a different date, 2013, comma, let's do November 11. Let's do the 4th of November. No problem there at all, 2013, November 4th. Let's say we want to have our month and our date come first. Let's say we do pd.timestamp 1/1/2015, January 1st, 2015. No problem, finds that date. Let's try something in reverse. Let's say I have my day first, day, month, year. Now, sometimes pandas is smart enough to figure it out. For example, if I have something like 1912, 2015, pandas can figure out that I'm referring to the day as my first thing here, because there's no month that has 19 as its number. Only 12 goes up to there. December is the 12th month. So it's going to figure out that I mean December 19th here. However, if we reverse this and write 12/19/2015, it's also going to give us the exact same date, because it can figure out what we want. So unfortunately, though, the caveat here is that if we do have something like the day first, let's say we want the 4th of March 2000. In this case, it's actually going to look at it as April 3rd, 2000, because it's going to interpret this as the month, and this as the month and this as the date, even though we meant to reverse them. So you do have to be a little bit careful. Generally, in cases like this, it's going to default to the most popular option, and writing month/date is the more popular way. But there are ways and other attributes that you can dive into, and other arguments that you can dive into that'll allow you to solve for those problems if they arise in your own custom data sets. But we can see here that it accepts a wide variety of inputs and is usually able to figure out what we mean. And let's say we want to add a time component. It's very easy. We can just add it to the end. So I'm going to stick with strings here, and let's say I do 2021, March 8th. And I'm just going to add a space here and write, let's say, my time with colons, 8:35:15, so 8:35 in the morning, 15 seconds in. There you see it's generated that date. Let's say I want to do something in the evening. Let's do the same day, but let's say I write it with AM PM syntax instead of military time, so I do 6:13:29 in the evening, which I designate with PM. You can see in the below result, it's converted that 6 into 18, which is 6 p.m. in military time. So as we can see, pandas is very versatile, very flexible in figuring out what we mean when dates come in this variety of formats. And that's especially helpful when you think about applying this operation to an entire series. maybe your server, stores dates and times in its own kind of unique way, and there's ways that you can customize and tell pandas how to interpret them all in a similar fashion. And most common formats like here, we can see it's just going to breeze through and convert to timestamps automatically. Now, as I mentioned, we don't have to feed strings exclusively to the timestamp constructor. We can also feed direct Python datetime objects. So what I can do here is call my timestamp constructor again, open my parentheses, and give it a direct date object, like let's say the 1st of January 2015. So this is just the syntax from my previous lesson where we created a date object from Python's datetime module. You can see here that Pandas has converted it to its own timestamp object without any time, of course. It defaults to midnight because we didn't provide it. And of course, if we instead give our timestamp Pandas object a Python datetime object, and we give it both year, date, month, hours, minutes, seconds, for example, 2000, February 3rd at exactly, let's do 9 o'clock, 35 minutes in rather, and 22 seconds there, that timestamp. Here you can see it's represented as a Pandas timestamp as well. So you might be thinking, well, we have a Python datetime object. Why the heck would we need a Pandas timestamp object? Well, it's sort of the same question as asking, why the heck do we need a Pandas series when we have a Python list? Well, because Pandas offers objects that offer a lot more functionalities and a lot more features. There's a lot more that we can do with a timestamp that we can do with a Python datetime object. We'll show some of these examples later in terms of date manipulation, like adding dates, subtracting dates, manipulating them, extracting components from them. But really, it's the same reason we use any custom library object over a built-in object. It just works better. It just works faster. It just has more flexibility. It offers us more things that we can do with it. So the timestamp is basically the Pandas way of doing the Python datetime. And in the next lesson, we'll dive into the datetime index object in Pandas, which is basically a huge storage container for storing these Pandas timestamps.